So I need to determine what shims I need to put under my posts, the 4 posts. And they're quite a distance apart, like 20 feet apart for the 2 sides, between front and back. And well, I certainly don't have a standard like a 4-foot level that's 20 feet long. My buddy has a rotary laser level type, which is awesome. I've used it before. I just love it. I think they call it a transit maybe. Anyway, it's awesome, but it's like a $1,500 tool. Anyway, I can't get a hold of it today, and I want to go ahead and determine what thickness of shims I need. So one way to do it is I've got this long piece of tubing. I've got like a 20-foot piece of 1/4-inch tubing. I've got it full of water with no air bubbles. And in order to do that, you have to siphon water out of a water jug and make sure that there are no air bubbles through the entire tube. Now, I don't know if the camera will pick it up. I think it can. Right at the end of my finger, that's the water level. And on this other one, there's the water level. Well, they are the same because gravity puts an equal force on the water up here and the water up there. So I know that this is the same height as that. Well, if I took this jug and moved it over here, I can now measure the reference height of this water versus that water. And when I measure the height from the water down to the floor and the water down to the floor, if the measurement is exactly the same, I know the 2 measurements are taken from an equal height off of the floor. But if this one is 2 inches, the water is 2 inches lower to the floor than over here, then I know that this location is 2 inches higher than this location. And so using this method, I spread my, it's called a water level. So I spread my measuring things out at the 4 corners of wherever the post is going to be approximately. And I measured it out, did this several times because this is not, I mean, it is an exact science because water will go where it's going to go. But due to, you might get an air bubble somewhere that you can't notice in your tubing, or there could be something that causes this to be less than kind of perfect. So I always recommend doing 2 measurements in one direction and flip it and do 2 measurements in the other direction. And then you average them, and that will tell you precisely where it is. Like I had one measurement that was 1/8 of an inch saying that that post was higher than this post. And then I reversed it, and the measurement said that this post was 1/8 of an inch higher than that post. So they were just opposite. So that tells me that they're actually level. So anyway, using this level, I determined that my shims needed to be, oh, well, it's about 1/2 inch on this side. So I cut a plate out that's exactly the same as the plate on the bottom of the hoist. And then I've built it up with this very serious, this is all 1/2 inch, 1/2 inch steel pieces. And I've just shimmed it up so you can see it. This plate is now the same height as my other measurements. And I, you know, if I put a level on it this way and a level on it this way, it's level in both directions. So this one is ready to go. The way you determine which post needs to be shimmed is you measure all 4 locations and determine the highest location. For me, it's this. So there's not going to be any shim there because it's already level both directions and it's the highest spot. Over here, this is what I need for my 2 shims. Remember these posts right now. This needed a plate and some shims, but not as thick as the other side. So I've done all that. Now I've got the whole thing shimmed up. The cable lubricating phase now. And I've shown you before how I washed the cables out with solvent, and I took them out of the solvent bath a couple of days ago. They've been just draining in this bucket, so they're dry. And I found one cable that had a burr on it. In fact, it's more than a burr. There was one strand that was broken. It's on this cable. I moved it separate from the rest, so I'll find it. When the cable's straight, you can't tell. But when you bend them like, well, it's harder to tell if there's a broken fiber or strand. But if you bend it like this, you'll often see the broken strand stick out a bit. So what I'm going to do, and I've carefully checked all the cables and I found just in this one. So I'm going to measure this cable and identify exactly where the broken strand is, identify which post this cable serves, and I'll be able to check precisely that location frequently as part of my maintenance routine for it. So I'm not at all worried about the strength. Like these cables are built with a safety factor of quite high, I would assume, over the actual capacity of the hoist. So the fact that one strand is broken that I found, maybe there's one or more others somewhere else that I'm not able to find, I'm not at all concerned about it, but I do want to monitor it. So now that we've got the cables completely dry, all the solvent has evaporated out of them, you want to lubricate them. Now you might be tempted to just take grease and go on the outside of them, but that grease may have a hard time migrating to the inner fibers the way that the solvent did, because remember the solvent went in there and probably washed out any lubrication. So you want to make sure that you lubricate the cable in its entirety through the whole cross section. The only way to do that I can think of is to put, and I'm going to lubricate it with gear oil, so 80-90 gear oil. The way I'm going to do it, I'm not just going to drizzle the oil here. I'm going to actually make a puddle and put this in and have it kind of bath in the oil and let it soak in. So yeah, now I'm in the assembly phase. I'm going to put the pulleys and shafts that hold the pulleys, or pins I guess they're called, in their locations. And I think after that, I probably will try to flip this ramp on its right side up and build this thing. Okay, giving you a little quick update here. Because you have to build it, square the ramps up, and then you drill your holes for the posts. So it's not like I thought. I thought I'd be mounting the posts in the concrete first and then building a hoist around it. That's not it at all. Things are starting to come together now. Got all the cables run. Setting up the cables on the pulleys or the sheaves, and then the sheave axle under here was the worst part of the whole project, trying to figure out which way the pulleys went, because I had the ramp upside down and I was looking at the diagram and I had to flip in my mind, flip the diagram over and mirror image it. So it took me quite a bit to get this straightened out, but I think I've got it now. Cables had to go, 2 cables have to go in the yoke and this way. And to do that, I threaded a rope through there and then drew the cables through with the rope. One of the cables goes this way and one of the cables pops out over there. One of the cables pops out here and one of the cables came from the cylinder, curls right around and goes back there. So when I lift it up, I'll be able to show you, the cable routing underneath, but it's a little difficult to do that right now. So I'm now to the stage where I will need to, what am I going to do next? I'm going to bring these posts into position. Now I had installed these things, these sliders, and in retrospect, they shouldn't have been installed. You put them on after you slide the yoke into the post. So yeah, little mistake there, but that's okay. I'll take one of them off, put the post in at an angle and rotate it around and then put the second one in. Then I guess I can start, I can put the safety ladder in the back. The safety ladders come in the instruction manuals. It says apply the rubber cushion or spacer or something. Down here, there's like a quarter sized rubber thing that must stick on there. I don't know why they would have anything that sticks on there. If you look at the big ladders for the front posts, they're really well made and they've got this little piece of metal welded on here in various places. And that keeps the ladder away from the back of the post and towards the locking mechanism. If those things weren't there, the locking mechanism could actually slide out. But because these are there, the locking mechanism can't slide out. I don't know why the front ones are built differently. So I'm actually, I don't have the red spacer that is described in the manual. So I'm actually going to weld on a little metal spacer on the bottom because I just think it should always be there. The way that this 4-post hoist gets assembled is you should flip this ramp over. This is the one with the hydraulic cylinder in it. Flip it over and run all the cables in it before you install it on here. I would highly recommend that because once you get it flipped the proper orientation like you see here, you can't get at the pulleys here, 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 and even the underside is somewhat restricted. So if you wait until putting the ramp in this orientation before you start running the cables and organizing the sheaves under there with the axle pins or the sheave pins, it's going to be very difficult. So that means that you have it flipped upside down, run all the cables, but when you do that, all the diagrams in the book are showing the cable routing for the hoist in the proper orientation, not the upside down orientation. So you really have to look at this and flip this around in your mind, sort of mirror image it. And it took me quite a while. I normally don't have that much difficulty figuring out puzzles, but in this case, it took me
probably good hour and a half to route the cables. They have to come out the pulley. And the other thing too is once you put a sheave in place, you can't change the cable. Like there's not enough clearance around the end of the sheave where the cable goes to slide the cable in and out. You have to have it right when you put it together. Okay, as I brought this ramp closer, I flipped it on its proper orientation now. As I brought this ramp closer, the cable that comes out and goes up here to this post, I fed it through there before this got right in place. And there are two cables that go that way, one to that post and one down there. I fed those cables in this yoke before bringing this right up onto there. So then the next thing is, I've got this in place with the cables run, this in place with the cables run. This I brought into the column enough so that I could tighten this, their neoprene sliding bushings there. And they each have 2 bolts, like 2 bolts on this side, 2 bolts on this side. I brought this in enough so that I could attach those, and the ladder was already in place in the post, by the way, and tightened right up so that it was high. And then put the yoke in, tighten the bushings on, and then you can drop the ladder down inside the bushings. Right now I have I use the floor jack to bring that yoke up high enough so that each of those are on the first lock. These posts have been shimmed, rough shimmed, they're not perfect yet, but shimmed, and I'm now gonna stop working on the, and I ran the cables up and they're just loosely in place there now. They're loose because the hydraulic cylinder is, let me see, it's been retracted more than is necessary for the hoist being at this height. They would tighten up if I lowered the hoist to the ground. So I'm done working on the front for now. Today I'm going to focus on assembling these front yokes, these kind of half yoke I call them, because they don't, this is an open front hoist. So I'll finish the assembly on these and then install them in the posts. In the manual, it talks about a bar that connects between this yoke and this yoke to keep them separated and keep them like at a specific separation. I don't have that. There it is right there, spacer tool. I don't have that, so I'm going to have to make that. So we've got the front yokes all assembled with rollers and bushings, and then the thin bushing, so that's a thick, that's a thin, and then a roller down here. I've disassembled and cleaned and lubricated all of the locking mechanism. I heavily lubricated this surface right here that contacts the ladder as it goes up and down. And so these are all fully kind of reconditioned as far as checking things, bushings, and so on. One thing that's obvious now that I'm kind of working through this is the more plumb your posts are, the less wear there will be on these bushings. In theory, if things are perfectly balanced, everything is perpendicular to the ground, gravity is pulling straight down, these bushings, really, there shouldn't be any wear. They should just be kind of centering the yoke in the column and not allowing the column to kind of run too far to one side or the other. So anyway, I'm going to be very particular when I plumb these up to make sure that they're good. My next step is to lay this down on its back and then route these rollers through that opening, slide it all down, and then stand it back up. And we'll see how that goes. As I stand it up, I'm going to have to take this cable and route it through that opening right there. And it will come up through here. So that's how it goes. Okay, so we've got our post lying down now, and you can see how this just drops in place like that. Now you want to make sure that your bushing stayed in place. The white thing in the center, right? They're in there. And also the black ones are there, those skinny ones are there, no problem. So the next thing is roll it back. Made that sound easy, didn't I? Why is it? Oh, okay. Doesn't want to go back because the ladder's in the way. I wonder if I wasn't supposed to have the ladder in there. Probably wasn't supposed to have the ladder in place. Anyway, I'll figure that out. And then I went to drill the holes. Now, to drill the holes through concrete, you need something called a hammer drill. Now, a hammer drill spins around, but it also bangs up and down, and that's the hammering action. So basically, you're going to drill all the holes, hoping that you don't hit rebar. I have, of the 18 holes, I have 4 left to go, and I haven't hit rebar yet. I'm so grateful for that. And I started with a smaller drill bit, like 1/4 inch, and then I went to like 3/8, and then 1/2 inch, and 5/8, and it's easier on the drill bits if you, especially the larger drill bits, they last a lot longer if you drill pilot holes. It's just basic, good practice drilling. If you're in an industrial environment and time is money and you don't have time for all that, probably you're just going to take the final drill bit size you need and drive it through. But that's not the way I did it. And I'm drilling, after I drill for a while, maybe 20 seconds or so, I'll take the bit and dip it in a bucket of water and cool it down. And then I'll go back in the hole 10, 20 seconds, and then back in the water 10, 20 seconds. All the while, I keep the drill spinning. So it just keeps the drill motor spinning and cooling. Your drill bits never heat up, and your drill never heats up. And that is the success. That's the secret to having the drill last a long time and your drill bits not wear out. So anyway, you're going to drill through. Now, a couple of things about drill bits. Some drill bits are like this. They look like a standard wood bit. And this is just a smooth, round surface. And you need a 3-jaw chuck for that, just like in a drill press. That's what that drill has. But one of my drill bits, the 3/4 inch size, has this, and this is called an SDS Plus. And it requires a special type of chuck. So rather than rent a drill, I found this one on sale, and it has an SDS chuck. I bought it for about twice the price that I'd have to pay to rent one. Now, true, if I rented one, it would be a bigger drill than that and probably faster going to drill the holes, but I don't care. So anyway, so after you get the holes drilled, you need to install the anchors. Now, in this case, where it's an open front hoist, the stress on these front posts is greater than in the back posts. So the holes in the anchors are for 3/4 inch in the front and only 5/8 in the back. Right now, I've got 5/8 anchors in my hand. On the left, you'll see a standard wedge anchor. So as you pound this down in the hole and then draw it up with the nut, it causes this wedge right here that's spinning on the left to wedge up on the end, and that's what seizes the anchor in the floor. When you put those in, they're in. You're never getting that out. So if you want to reposition the hoist someday, the anchor is a total loss. You got to grind it off flush to the floor, or if you drilled your hole deeper than you need, you can probably pound it down out of sight. But I don't know how long I'm keeping this hoist. Maybe I'll get another one someday. So I didn't want to have 18 of these wedge anchors as waste. So instead I bought screw anchors. In fact, there's probably another name for them. All these are Hilti, and the one on the left, the wedge anchor, is called a KWIK Bolt 3 or a KB3, and the one on the right is a Hilti KWIK HUS, HUS, and I bought 7-inch anchors because my floor under the front is 7 inches, so no problem there. In the back, I actually had to cut about 3/4 of an inch off of them for the front. In the back, it's a little less than that, 6 inches, so I'm going to cut a full inch off of these anchors before I screw them in. So basically, for either the wedge anchor that you've pounded in or the screw anchors that you're going to screw in, you just simply get a ratchet with the socket and tighten the nut down, and the wedge anchor will rise slightly while it's wedging, but after it rises a certain amount, it shouldn't rise anymore. And these screw down easy until they contact that plate, and then it's just like it screws easy, and then done. They will not turn. Now, you may ask, why did I use wedge anchors and screw anchors in the same application? At the time I bought them, I really didn't know much about the screw anchors. I wasn't sure about their tensile strength, so I thought, okay, the 3 most important anchors out of the 5 on this post are on this surface, so I'll use the 2 with the wedge that I'm familiar with, and then I'll use this one and these 2 on the sides that really don't do much with the screw. Upon further investigation and looking at the specs, the screw anchors at 7 inches or 6.5 inches embedment in the concrete, they're actually stronger than the wedge anchors at the minimum spec in the rotary hoist manual. So in fact, my screw anchors are stronger than the wedge anchors recommended by the manual. So anyway, I don't know if anybody else has comments about screw anchors versus wedge. You can certainly leave your comments below. But that's the update on anchoring this thing down. So, after the hole's drilled and blown out with compressed air, you want to check it to be sure the hole's deep enough to accommodate your anchor. And so I just took a coat hanger and I can feel a couple of spots. So it's this long and my anchor is this long. So you can see between my finger right here, my finger and the end of the bolt, it's like 1/4 of an inch. So I know the hole is 1/4 of an inch deeper than it needs to be. So get your anchor in there and you really want to try and screw this in straight. If they go crooked, you can just keep driving them and they'll straighten up, but that obviously erodes the concrete at the top of the hole and doesn't make your anchor as strong. So you definitely want to go in, you want your hole drilled straight or plumb to the ground and perpendicular to the ground, and you want the anchor to go in the same way. Hook it up to manufacturer's specifications. Once you have all four posts attached, anchors all torqued down, then you check the anchors check the columns to see if they're plumb to the ground. And if they're not vertical, then you can back these anchors off and shim them, but don't mess around with that a lot. Like, you'd prefer to never have to back that off. You can back it off a little, shim it, and then, you know, rotate it back. When I say back it off, I mean like 1/4 or 1/3 or 1/2 a turn, enough so that when someone pulls the top of the column away, you can fit something thin under there. Okay, folks, so we're getting near the end of this video. One thing I'll point out is I did wash the cables because I had dirt on them, and of course I washed the dirt off, but all the lubrication as well. And so I talked to a rotary hoist dealer, and they said that they recommend rust check, but they said they recommend the red, not the green. The red is thinner and will kind of permeate through the strands of the cable, whereas the green is too thick and won't go through it. This post has airlocks, and the airlocks, when the post is not when it's not resting on the locks and you press this lever down, and not that one, this one, when you press the lever up, it will cause the airlock to retract. 3 of the 4 worked perfectly, but that one down there didn't work, and it just needed to be cycled about 25 times, fluid pumped through it, and now it seems to be working reliably. So just like any other 4-post hoist, you press a button to make it go up, and then there's a hydraulic relief to make it go down. Folks, well, here's the big reveal. Oh, that's the size it goes.